Now let's take a look at expressions that have variables in them. Normally, variable expressions are tougher to deal with than numerical, but in the case of what you're going to be asked to do with negative exponents, this is actually a bit easier because you do the exact same conversion from negative to positive exponents, but because the expression is not numerical, there's nothing for you to solve. So let's take a look at example 7. We have to rewrite this expression without negative exponents. The rule, if you again remember, a to the power of negative n is 1 over a to the positive n. So c to the power of negative 4 is 1 over c to the power of positive 4. That's really it. You rewrote the expression without negative exponents. Let's take a look at the next example. 1 over k to the negative 3. If you remember, our shortcut is that we take the expression that's raised to a negative power and move it into the numerator, changing the power from negative to positive. So that's just k to the third over 1, which is k to the third, right? It's just like with numbers, only nothing to compute. Example 9. We have this expression, a squared b to the negative third over 5c to the negative 12th power. Again, you focus on the expressions that where we are raising to a negative power, the b to the negative third and the c to the 12th. And that's what has to be moved. So a squared stays right up top because nothing raised to a negative power here. 5 stays on the bottom. The b to the negative third moves to the bottom, becomes b to the third. C to the negative 12 moves to the top, becomes c to the positive 12. And that's it. Nothing more to simplify here. Example 10. So let's simplify this expression. We're multiplying exponential expressions. So remember, we're going to multiply the corresponding parts. 8 times 6 is 48. That's the numbers. When we multiply x squared by x to the negative 7, we keep the base and we add the exponents. 2 and negative 7 is negative 5. So that's 48 x to the negative 5th power. And now we shouldn't write our answer with a negative exponent. So we will take the x to the negative 5 and move it into the denominator, right? Remember that you can think of a 1 being in the denominator. And so you have 48 over x to the positive 5. And there we go. Example 11. 35m to the 4th n to the negative 8th over 21m to the negative 4n to the 3rd. There are a few different ways of working the problem. I'll just go with the most straightforward way, which is to say 35 and 21, you can divide by 7 to reduce. So 35 divided by 7 is 5. 21 divided by 7 is 3. The exponent on the top is bigger for m. So when we subtract, now when you subtract, be careful, it's 4 minus negative 4, which is positive 8. So that's m. Right, that's positive 8, so that's m to the 8th power. The power for n is bigger on the bottom. And when we do the subtraction, 3 minus negative 8 equals 11. So n to the 11th on the bottom. One of many ways to do it. So there's your answer, 5m to the 8th over 3n to the 11th. Let's do one more example. This example has almost everything that, or maybe everything that that we have covered about exponential expressions so far. But we're not going to be intimidated by any of this. We're just going to take this step by step. We have a fraction, and in the numerator of that fraction, we have multiplication. So, and same thing for division. That's what we're going to do. We're not going to worry about anything else. We're just going to multiply the expressions on the top, multiply the expressions on the bottom, and go from there. So 4 times 9 is 36. When we multiply the a's, 3 and -3 actually equals 0. So the a's completely cancel. And b, -5 plus 2, when we add the powers, right? -5 plus 2 is -3. So that's b to the -3. Again, there's no point of writing a to the power of 0 because a to the power of 0 equals 1, and multiplying by 1 doesn't change anything. That's what I meant earlier when I said that it canceled. Now let's do the bottom. 6 times 3 is 18. A to the -4 times a squared. When we add the exponents, -4 plus 2, we get -2. And when we multiply the b's, remember this b is like b to the first power. And so we have 1 plus -4, which is -3. So that's b to the power of -3. Okay. Now it's time to simplify. You can divide 36 and 18 by 18, so that just becomes a 2. The a to the -2 can move up top to become a to the +2, right? Notice there's no a for it to interact with, so we can just make that move. And b to the -3 and b to the -3 will completely cancel. So they're gone, and there's our answer. You can 2a squared over 1, or in simplified forms, you can just say 2a squared. And so as you can see, when we have a more complicated expression, don't worry about it, just take it step by step. We have to multiply, we multiply, divide, divide. If the power is 0, you know, it equals 1. If you have a negative exponent, don't worry about it until the very end. And then just move it up top or move it to the bottom if it was up top to make the exponent positive. No big deal. Well, with this video, you now know how to work with negative exponents, and you can start on your homework. Good luck.